Assalamualaikum warahmatullahi wabarakatuh. My name is Alif Putera bin HAMIDIN. I'm from class J4 CEEC 1104F1. My ID number is 2021206878 and I will be presenting about soil stabilization. Introduction. What is soil stabilization? Soil stabilization is the adjustment or maintenance of one or more soil features to enhance the soil's engineering qualities and performance. Stabilization can be accomplished by adding stabilizing material to an undisturbed soil deposit or by mechanically mixing natural soil and stabilizing material together to create a homogeneous combination. The aims and objective of this project is to determine the particle density and specific gravity of soil using density bottle, to determine the plastic and liquid limit of soil sample, and finally to determine the effect of addition of Pofa in soil stabilization. The method used to determine the effect of additional soil stabilizing agents are particle density test, liquid limit test, and plastic limit test. Particle density is the ratio of the mass of the particles to the mass of the water they displace. On the other hand, liquid limit is the water content where the soil starts to behave as a liquid. And finally, plastic limit is the water moisture content at which a thread of soil formed begins to crumble. Methodology. Firstly, particle density test. The apparatus and materials used for this test is 20 gram of soil sample, 1.2 gram of Pofa, density bottle with stopper having capillary hole at its center, wash bottle containing distilled water, vacuum sets, stopwatch, funnel, and weighing balance. Firstly, the density bottle and stopper were cleaned and dried properly. The dried density bottle with stopper was weighed and recorded. About 20 gram of oven-dried soil sample and 1.2 gram of Pofa was taken and poured carefully into the density bottle using a funnel. The bottle with the sample and stopper was weighed and recorded. Distilled water was poured to make the density bottle half full and then were mixed together. Entrapped air was removed by applying partial vacuum for 10 minutes. After removing the density bottle from the vacuum, more distilled water was poured into the bottle and completely filled without any entrapped air bubble. The stopper was then placed on the bottle. If the capillary of the stopper is not full, drops of distilled water is filled in the capillary. The bottle filled with water and soil samples with stopper was weighed and recorded. Then, the bottle was emptied and filled entirely with distilled water. The mass of density bottle with water and stopper was weighed and recorded. Finally, the steps were repeated for another 2 observations to obtain an average specific gravity of the soil sample mixture. Liquid limit Casagrande test. The apparatus and materials used in this test are 200 gram of soil sample, 12 gram of Pofa, Casagrande liquid limit device, grooving tool, spatula and palette knives, moisture cans, wash bottle containing distilled water, weighing balance, glass plate, and drying oven. 3 empty moisture cans were labeled and weighed. Then, 200 gram of soil and 12 gram of Pofa was placed onto a glass plate. The soil and Pofa was thoroughly mixed with a small amount of distilled water until it appears as a smooth, uniform paste. The liquid limit apparatus was adjusted by checking the height of the drop of the cup. A portion of the previously mixed soil was placed into the cup of the Casagrande apparatus at the point where the cup rests on the base. The soil mixture was pressed down to eliminate air pockets. A grooving tool was then used to carefully cut a clean straight groove down the center of the cup. Then, the crank of the apparatus was turned at a rate of approximately 2 drops per second, and the number of drops that it takes to make the two halves of the soil came in contact at the bottom of the groove along distance of 13 mm were counted. If the number of drops exceeds 50, then remix the entire soil specimen on the glass plate with a small amount of distilled water added to the soil mixture. A sample was then taken, including the soil on both sides of where the groove came in contact. The soil was placed into a moisture can and was immediately weighed. After that, the entire soil specimen was remixed on the glass plate with a small addition of distilled water to increase the water content so that the number of drops required to close the groove decreased. The steps were then repeated for 2 additional trials, producing successively lower numbers of drops to close the groove. One of the tests shall be for a closure requiring 30 to 40 drops, one for between 20 to 29 drops, and one for a closure requiring 10 to 19 drops. Plastic limit test. An empty moisture can was weighed and recorded on a datasheet. 20 grams of the original soil sample that have been separated was taken. The soil was rolled to form a ball shape and cut into 2 pieces. Then, each piece was formed into a ball and cut into another 4 pieces. The soil was then formed into an ellipsoidal mass by rolling it between the palm. Sufficient pressure was used to roll the soil into a thread of uniform diameter. The soil is rolled until some cracks appear on the soil. When the diameter of the thread reaches the correct diameter, which is 3.2 mm, the thread is broken into several parts. The pieces are kneaded and reformed into ellipsoidal mass and re-rolled. The step continues until the soil can no longer be rolled into 3 mm diameter thread. The portion of the crumbled thread were gathered together and was placed into a moisture can. The mass of the moisture can that contains the soil was weighed and recorded. Then, the moisture can from the liquid limit test and plastic limit test is placed into an oven for at least 16 hours. Summary of findings. From the data obtained from the test, it can be determined that the soil without 6% addition of Pofa has a particle density of 2.6 grams per centimeter cube, while the soil with the addition of 6% Pofa has a particle density of 2.57 grams per centimeter cube. It can also be seen from the graph that has been plotted that the liquid limit of the soil without 6% addition of Pofa has a 25% liquid limit, while the soil with the addition of Pofa has a liquid limit of 30%. The plastic limit obtained from both soil samples was 11%. From the value of liquid limit and plastic limit, a plasticity index can be determined, where the soil without addition of Pofa has a plasticity index of 14%, while the soil with the addition of 6% Pofa has a plasticity index of 19%. Both soil samples has the same classification, which is clay of low plasticity. Discussion. The particle density test indicates that the soil sample without the addition of Pofa had a higher density compared to the soil sample with the addition of Pofa. This indicates that the soil sample with no addition of Pofa has a lower soil porosity, which means that it is stronger than the soil with addition of Pofa. This decrease in strength may be caused by the ratio of soil to Pofa, which may be not optimum. The liquid limit of the soil with the addition of Pofa is higher than the soil sample without the addition of Pofa, while the plastic limit of both soil samples remains the same. A plasticity index can be determined for both soil samples where the soil with addition of Pofa is higher than the soil without Pofa. Both soil samples can be classified as clay of low plasticity. However, due to the higher liquid limit of soil sample with Pofa, it shows that the soil sample is able to handle higher force to deform and is able to deform more before cracking. Conclusion. It can be concluded that the addition of Pofa is suitable for the soil stabilization with the correct ratio of soil to Pofa. In addition, stabilizing can enhance in situ or natural soil condition and also avoid costly remove and replace operations. In this test, many errors could occur, such as environmental, human, and instrumental error. Environmental error may occur due to the weather condition, where hot weather could cause the soil sample to be dehydrated, or windy conditions could cause a sensitive weighing balance to display inaccurate readings. This error can be minimized by conducting the test in optimum weather conditions. Human error may occur during the particle density test, where the density bottle was not filled up fully. To avoid human error, students must be aware of the steps to be followed as to fill the density bottle fully. Finally, instrumental error can occur when the weighing balance is not constant with its reading, causing multiple readings to be displayed with the same sample. To avoid this error, the apparatus used must be checked beforehand to avoid using faulty equipments. Cost contribution. From a student's point of view, there are many advantages of this project implementation. Some of the advantages of this project implementations are practical applications, problem solving, understanding soil properties, teamwork and collaboration, and data analysis. In terms of practical application, these projects enable students to apply the concept they have learned in the classroom to actual situation. Through this project, students can learn how specific substances or additives can change the characteristic of soil, which is useful knowledge for upcoming engineering or building projects. In terms of problem-solving skills, students are able to gain the ability to recognize probable sources of error, suggest improvements, and even enhance the accuracy as well as reliability of the studies. In terms of understanding soil properties, students can learn more about the relevance of soil qualities through this activity. By comparing particle density, liquid limit, plastic limit, and plasticity index, students can understand how these elements affect the strength and suitability of the soil. In terms of teamwork and collaboration, even though this project is an individual assignment, students still have to work together to conduct the experiments. Finally, data analysis. Students are able to learn on how to gather, organize, and analyze data.